In this video, we're going to be evaluating logarithms, and then we're going to use the change of base formula so that we can evaluate logarithms in our calculator when it's not a common or understood base. So the first two examples, we're going to evaluate each of the following logarithms, and we're going to round the answer to 4 decimal places. So notice in number 1 and number 2, neither of these have a base written. That means they're the understood base. So since there's no base written in number 1 for the common log, the base is understood to be 10. This is the base that your calculator assumes that you mean when you ask it to take the log of a number. So if you type in your calculator log of 52, your calculator assumes that you mean base 10. So at one time, calculators could not handle anything other than base 10 or base E, but now it's pretty common to have a button on your calculator that can do it for you. So sometimes you might have a button that looks like this, where you can input a different base, so a base other than 10, and your calculator will do it for you, and you won't even really need the change of base formula. But if your calculator cannot do that, or if you need to show work, like in some of your homework problems for me, you will need to show what you get when you write or when you use the change of base formula, you'll need it for that. So in number 1, if the base is not written, it's understood to be a 10, and you just enter that in your calculator and see what you get. So when I do that, let's see, the log of 52, rounding to 4 decimal places, so I get 1.7160033, etc. Now I purposely wrote more than I needed, so I want to end my decimal here, right? I want it to be 0.716, and then I have to decide if it's going to be a 60 or a 61. Just a reminder, you look at the number after that. If it's 4 or less, you keep the 0 the same. If it's 5 or more, the underlying number is 5 or more, the 0 in red will become a 1. So since the number underlined is a 0, the red stays a 0. So rounding to the nearest 4th decimal is 1.7160. Number 2 is similar. This is the natural log. And when you have a natural log and there's no base written there, it's understood to be E. So this is going to be E. And your calculator assumes that that's what you mean. So I'm going to do the natural log of 3. I will get 1.09861228, etc. So I want 0986. Oh goodness. I want to end here at the 6, and then I look at the number after the 6 to decide if it stays a 6 or it goes up to a 7. So since the number after the 6 is a 1, that means that the 6 is going to stay a 6. So rounded correctly, I will have 1.0986. So simple enough. You just put it in your calculator and make sure you round appropriately. If you look at number 3 and 4, the issue here is that they have a different base. So both of these are common logs, but instead of having the understood base of 10, number 3 has a base of 13, and number 4 has a base of 5. So let's see how we can use the change of base formula to rewrite these logarithms using the common log with an understood base of 10. So first, notice in the formula, originally my base is b, but my new base in my fraction, both of them are base n. N can be any number you want. So if for some reason you wanted to change them both to log base 2, you could. But really what you're trying to do is change it to base 10 so that you can plug it in your calculator. So generally when you use the change of base formula, it'll be to a base 10. So notice here that what I'm taking the log of originally, so the log of m, goes on top. And my base is going to become an argument on the denominator. So it's going to be log of b on the bottom. So the original argument is still the argument in the numerator, but the original base is now an argument in the denominator. So just practice this a couple times and you'll be able to get it. What it boils down to is you're going to make a fraction. There's going to be a log on top and a log on bottom. You're going to have the understood base of 10, so you're not going to write a base. The top is going to be what you were taking log of originally. So the log of 45 goes on top, and then whatever the original base was is going to be what you're taking log of on the bottom. So using the change of base theorem to rewrite using the common log, this is the fraction that you would get. So log of 45 over log of 13. And if you want to find out what that is, just type it in your calculator. So you would do the log of 45 and divide that by the log of 13. Rounded to 4 decimal places correctly is 1.4841. And after the 1 is a 0, so that stays a 1. The last one that we will look at is log base 5 of 8.5. So same thing as number 3. We're going to see that we don't have a base of 10, so we want to use the change of base theorem. So it will be the log of 8.5 over the log of 5. And if we type that in our calculator and round appropriately, let's see, we will get 1.32. Okay, so I have 969. So that 9 is going to round up. It's going to round the 6 up to a 7. So 1.3297, rounded appropriately. Now in the directions it said I could rewrite using the common log or the natural log. So I could have just as easily, so this is an or to both of these, instead of using the common log, I could have used the natural log and said the natural log of 45 over the natural log of 13. And if you put that in your calculator, you will see that you get the exact same answer. Same is true for the other one. Instead of using the common log, you could have used the natural log, and that would have been fine as well. Now it's just changing the base to an e instead of the base 10, but you get the same thing. So either way, 1.4841 is the top, and the bottom one, you still get 1.3297. So if you want to use the common log, great. If you want to use the natural log, fine. Either one is fine.